All right, so let's go ahead and get started and talk about what an acid and a base are. So there's various definition. The definition we're going to learn is Arrhenius. So Arrhenius is a person who defined acids and bases this way. There's also a Lewis acid and base, Lowry Bronsted. So there's different definitions, but we'll stick with this definition. So an acid is anything that dissociates into an H plus ion when dissolved in water. So for example, the most basic one, like hydrochloric acid. So when hydrochloric acid gets put into water, it becomes H plus and Cl minus. It dissociates, it dissolves. And so hydrochloric acid is considered an acid. Why? Because it creates H plus or dissociates into H plus. Anything that dissolves into an OH minus ion when dissolved into water is a base. So for example, NaOH, when we place it in water, dissolves into Na plus and OH minus 1, right? And so since it creates or dissolves with OH minus 1, it's considered a base. So to measure how acidic or basic something is, we use what's called the pH scale. And so the pH scale is the measurement of hydronium ions. So hydronium ions are H plus ions. And the scale is between 1 through 14. So if you have a high concentration of H plus ions, the pH is less than 7, and so you're considered acidic. So a pH less than 7 has a high concentration of H plus ions, and therefore is acidic. Something that is basic has a pH that is greater than 7 and has high concentration of OH minus ions. If the ions are equal to each other, concentrations are equal, then the pH is 7, and that we consider that neutral. All right, so let's go ahead and fill this. So what are some properties of acids and bases? So acids and base, so when they're dissolved, releases, so acids release H plus, bases release OH minus. Acids taste sour, whereas bases are bitter. And then the most common sour is like you have citric acid, right? And so, a lot of lemons and oranges and that kind of stuff are slightly sour. If you're acid, then you're less than 7 on the pH scale, more than 7. The conductivity, this conducts. Acids conduct and bases conduct. And the reason why is they both dissolve, right? So they create an H plus and then something else minus, right? Like Cl minus. These plus and minus, that's what conducts. They're called electrolytes. You might be familiar with electrolytes in like Gatorade, that kind of stuff. These are the things. These are the ions are actually electrolytes. Acids react with metal. They can cause metal to corrode, so yes, it reacts. And then bases do not react with metal. All right, so if we have a pH, how do we know if something's acid or base? Well, we can check the pH, right? And you can use what's called a pH meter, and the pH meter can actually tell you the exact pH. But let's say we just want to do it quickly, right? Well, we can actually use these indicators. So an indicator, one example is a phenolphthalein, right? So phenolphthalein is pink when there's a base. If it's acid, it's clear. So it's a clear liquid that is in the presence of acid. Red litmus paper. So red litmus paper will turn blue when in the presence of a base. So if it's a base, it turns blue, stays red if it's an acid. There's a common theme here, by the way. Blue colors tend to indicate base, red tend to indicate acid. So if you have if it's base on a blue litmus paper, it'll stay blue, and then if it's red, it turns red, it'll be acid. pH paper has their own, but generally, like blue, green, those tend to be bases, and then like red, orange, like more towards that side, that tends to be acid. And then a universal indicator, you actually have to, like, you have to use, like, you use a like a key or something, so it tells you. So these are the common indicators that we use to determine if something is acidic or basic. Oops. Let's keep on going. All right, so a neutralization reaction is when you add an acid and a base. When you add an acid and a base, they neutralize, meaning the pH becomes 7. And so you have a salt plus water. So for example, let's do an example. So hydrobromic, well, what is hydrobromic? Anytime you see hydro, it means it's what's called a binary acid. It's hydrogen with the ion bromide. So plus calcium hydroxide. Calcium is a +2, hydroxide is OH -1. And so this is CaOH2. What they'll do is they'll recombine, so we'll form water, right? Because we'll have H plus with OH minus, giving us H2O plus a salt. In this case, it'll be calcium and then bromine, right? And then what you'll have to do is you'll have to balance this out. So here I have 2 bromines, and let's see, I think I'll need 2 oxygens. So it looks like it should be like this when I balance it. Sulfuric acid, remember, so sulfuric acid, since it doesn't have hydro, is a instead of a binary, it's like a ternary, what we call ternary. So sulfuric acid is going to be H plus with some type of polyatomic. Now, anytime you end in IC, it's gonna you're gonna look for the polyatomic that ends in ATE. So in this case, it's sulfate. So sulfate is SO4 minus 2. So these are the 2. So if it ends in IC, if it ends in OUS, then it's ITE, right? So this is H2SO4 plus potassium hydroxide, K plus 1, and OH minus 1. So this KOH, just a 1-to-1 ratio. So we'll get water, and then these 2 will pair to get K2SO4. You need, okay, and then I'll just go ahead and balance it. So this is a 2 here, and you'll need a 2 here. All right, so that's a neutralization reaction. You take an acid and a base, you create a salt. In these cases, these are salts. It's just a name for a solid, or not a solid, but an ionic compound. It's just a common name for an ionic compound plus water. All right, so you got some homework you can work on.